In GitHub, we have the Virtual Cloud Lab organization where all the GitHub repositories are stored. So this is fully aggressively open source. Everything is in the open. And also all the packages have very as permissive as you can have a license. So it's a what is called an MIT license. That means you can do with code whatever you want, right? So if you're working with companies and they want a model and they're worried about whether they can use it in a commercial setting, that's allowed. It's no problem. The only thing that we add is that, of course, they attribute the fact that they're using VPL, right? So that is mentioned, okay, we're using these packages, but otherwise there are no restrictions whatsoever. So this is compatible with any context. Okay. And of course, it will be a publication soon-ish. So it will be nice if you ever use VPL to, in the context of a paper, to cite that publication. Okay, so for today. That's interesting. I had a collection of tutorials. I don't think we will go over all of them, but at least I want to do the algae and snowflakes so that we get the basics and then do as much as we can from the tree forest series. Okay. I sent a link yesterday to everyone that I was aware of who was associated to the Outlook meeting, which I guess was everyone here. In case you wanted to follow along, okay. So this is the HTML version that I made if you want to read it or print it. But then we also have the original Markdown, right? So what I'm using here is Visual Studio Code. So that is my personal preferred way of writing Julia code. It's also what I recommend to most people. Okay, it is compatible with a Word laptop. Okay, and the nice thing is that you can write your code and execute your code in the Julia console in a more easy way. But again, you don't have to use this. If you write a Markdown file, I don't know if everyone had seen a Markdown file before, but basically it's text written with a special formatting Markdown. Then you have chunks of code. From this, you can generate a PDF, you can generate an HTML document, but you can also run the code in the code chunks inside VS Code. And that's what I'm going to do, right? Because then I can show you the text and the code being done. So you don't have to copy paste from the website into a Julia. So that's the whole point. Okay. So first, by the way, is anyone going to follow along, try to type code or run the tutorials in parallel to me? Yes? Yeah. Okay, good. It's not necessary. I mean, it's also recording, so I will share the recording later if you want to go back to this. But basically, if you want to follow along, you will need to install a series of packages. This is code to install it.
Sorry.
Yeah.
I'm so slow.
Yeah.
So if I want to do the tutorials with you, then I want to download the tutorials.md.
Well, you want to load the whole GitHub repository. Sorry.
But the one that you, but then how? Sorry, I am in GitHub.
Okay.
Very.
Then for now,
because there's no download button. So I'm
confused.
Because this is what you shared. Can I download? Oh, where did you go do that?
Code.
Oh, let's go. Okay. And then I just open that. Okay. Yeah.
Do you have Visual Studio Code, but then you don't have Visual Studio Code installed, or do you?
Yeah.
Okay.
This one, right?
Oh. Just open now. Visual Studio Code is open.
Open here. Now it imported everything. Okay, thanks. Yeah.
If you open Visual Studio Code, what I have here is what's called a Julia project. And you know that it's a Julia project because it's a folder that has this project.toml. Okay, so whenever you see that, this project.toml includes all the dependencies for the code. So all the packages that are needed to run the script. Okay, so what we can do is that we can open the Julia console, and you do that with Control-Shift-P. So Control-Shift-P, and then you will have all the commands, and one of them should say Julia star REPL. Okay, that will open up the Julia console. Okay. So if you set up Visual Studio Code with the plugin correctly, then you should see Julia show up. If not, that means you don't have the plugin.
Again, I go to project.toml.
No, so you don't need to open project.toml. Okay. That was just to illustrate. So you need to do Control-Shift-P. Yeah.
Yeah.
And if you have the Julia plugin, then it should say Julia star REPL somewhere. You can also type, and then it will search.
Yeah.
And
Julia what? Many Julia.
Start REPL. So REPL is a console.
Okay.
Read, evaluate,
Start REPL. REPL.
Yeah, got it. Yeah. Yeah. So then you will see this popping up. So you can test that Julia works by doing 1 + 1, and you should get 2. Right. Okay, so if we are in the Julia console, we can access the package manager, Julia, which is, let's say, the program within Julia that you can use to manage all the packages. Okay. And there's a shortcut to do that. We can use the pkg package to manage the package. So that's what I have in the tutorial. Okay. But if you're sent a Julia project, that means a folder with the project.toml file, then you can access the package manager by pressing this key. So that is the key that has a closing square bracket. Okay. If you press that, you should see that the prompt changes to something in blue. Okay, that's the name of the folder, and it's a pkg. Right, and then here you can type instantiate. Instantiate. If you press enter, that will look into the project.toml, and it will download all the packages that are listed there and install them in your machine, and they will become available within this project.
So now we are adding the packages Virtual Plant Lab, EcoFish, SkyDome, and GL.
So you're adding this one. So Virtual Plant Dome, SkyDomes, EcoFish, and also a few extra packages are needed. For
these are not the ones that you put in that file where you just with the text. That these are more. When you are going to the text.
Is that true? Oh, true. We also need GLMACI. True, you're right. You're right. So I can show you, but it's if people run instantiate, it might take a while to run. If you don't. Closing square brackets.
Closing square bracket.
Yeah. So in a English keyboard should be next to the enter key.
Okay, yeah. Okay.
Nice.
That's just possible your tiny keyboard. Yeah. It's function M.
If we want to add a package, because you're right that GLMACI, for example, is not in the project.toml. In this package mode, so the blue prompt, we can type add and then GLMACI. Okay, so if you add that, then it will download and install that particular package. Okay. So here you have sort of the programmatic way to do it, and this is the more interactive way to do it. In this case, once I tap add GLMACI, it will actually update the project.toml file. So now you see that GLMACI was added as a dependency, right? So the thing I want to say here is that I recommend when you're writing your model that you create a Julia project, which basically means a folder with a project.toml. And I mean, if you Google how to do this, there will be a instruction somewhere in the documentation how to do this. It's quite easy, right? Because in this way, you can keep track of the dependencies and the versions. And when you share that folder with someone else, they know exactly what they need to install. And it's also more compartmentalized, right? So you can have different projects in your computer with different dependencies. Okay. If you want to get out of this package mode, you just press the backspace. Okay. So backspace, so the delete, well, not the delete key. Backspace key. Is anyone still busy with this?
It's instantiating.
Yeah.
Okay. Okay, well, I can talk for a while and then people will catch up.
So just to make sure, we need to instantiate and then afterwards manually add GLMAC.
Yeah, you have to add GLMAC because I did not run this after I have the tutorials. So GLMAC is to make sure that we have the graphical backend for the 3D language. Okay. So now you're getting your first Julia experience, which is that you need to wait for 15-20 minutes every time you install the packages.
We're used to growing, we have to wait all the time.
So basically in Julia, you're going to have to wait when you install or after the packages, because then it's doing some compilation ahead of time. It's called pre-compilation. And then the first time that you call a function within a session, it will be compiled. So that means that the first time when you're typing your code and you're running your model, the first time it will take longer because it needs to compile all the functions that are being used. Okay, also the ones in the packages. Okay, the ones that you write and the ones in the packages. Once they're compiled, then it goes much faster. So for example, the first time that you do 3D rendering, it takes a little while because you need to compile all the code in Mackie. The second time is instant. Okay. That's something you need to take into account, especially when you're trying to measure the performance of your model. Let's say the first time step is going to be ridiculously slow because it needs to compile the model. Afterwards, it gets faster. And I have to say that in the past, this was really annoying in Julia because you have to wait a lot. And that is the one thing that we improved on. But now you are getting a really pleasant experience compared to 6 years ago. So don't complain. Okay, sure.
It's not like in R, which I always struggle with, is that I first have to install it, save to the library, and then every session I run, I have to like open the package.
Yeah, you have to do the same here, right? You have to do the same here. You install it
Now
once.
I install it, but every time I have to install it.
No, in R you don't have to install it. Here you don't have to install it. You
But
install
why
it
is
once.
this taking so long?
Because the first time that you installed it.
Oh, this is the first. Oh,
Yeah.
I thought every time. we do
If you
this
come
now.
back to this tutorial, or actually anywhere in your computer, because they have
Yeah.
a place, if you're using the same package, the same
Yeah.
version, it will not do this again.
Oh, okay,
Yeah.
yeah. What was it called? Mackie?
GL Mackie.
Why don't you use Orion?
Sorry?
Why don't you use Orion as for Jupyter
Jupyter
notebooks of Julia?
Because not everything runs properly in Jupyter Notebook. There's a few sticking points, and also Jupyter Notebooks are really bad for collaboration. Like the way the data is stored is not a plain file. Like here, Markdown file is really just plain text. So if I make a change to a file, then I commit it to the GitHub repository. Is the one thing that I've changed. That's what shows up in the commit. Jupyter Notebook, it's almost like a Word file where the text that you write and the actual storage, it's a little bit decoupled. So for collaboration, it's really annoying, right? here, when I run the code, it's really just sending it to the console, so everything works. I don't have to worry about compatibility with Jupyter, and it's a plain text file. So I personally prefer that.
And the same goes for this Orion, the Orion scope, the
We Pluto.
different plans. Same system.
So Pluto is an attempt to build Jupyter Notebook, but that is actually a little bit more complicated. So Pluto has the active programming style that I don't like it that much personally, but also because I haven't used it. But we can use Pluto. The Pluto is a little bit more compatible. Okay, I'm going to continue because although I think some people still trying to catch up with instantiate, but
Yes.
here I'm basically going to talk a little bit more about about VPL and how it works. So we're going to start with a very simple model, and I like to start with this model because it is, to my knowledge, the first or one of the first L systems that this was ever published, right? That's when Aristide Lindemeyer was working with Utrecht and trying to figure out these rules for creating fractal growth. One of the simplest L system was this linear, basically linear growth model that represents a multicellular algae that is growing in the apex. Right? So I can switch to the HTML because it's easier to read. Okay. So this is a very simple model, and here I have the classic L system rules. So you start with A, and then there are two rules. In every iteration, A is replaced by A followed by B, and every B is replaced by A. Okay, so basically the growth happens through these A symbols, and then the B is replaced into an A so they keep growing, right? And basically this is going to end up being, there's a filament that grows linearly. We keep adding, stacking A items, okay? This will be the classic L system rule. So how do we do that in VPL? Okay. So the first thing we need to do is that we need to load the package. Just let you know. In R, you will do library, and the name of the package here you use UC virtual plan wrap. Right? There's two ways to import a package in Julia, either with the keyword using or the keyword import. The difference is that when you use using, all the functions become available in your code directly. When you use import, you get access to the module virtual plan lab, but then if you want to access function, you need to prefix. So you will have to say virtual plan lab dot and then the name of the function. The reason why you have, and there's more sophisticated ways where you can import specific functions, etc. So it gets a bit more complicated. The reason why you have these different ways of loading packages is to deal with the name clashes. Right? So if you say using virtual plan lab, and now you want to create a variable called node, you're actually trying to overwrite the node that is defined with virtual plan lab, and then Julia will scream at you, say nope. And you hope that it does, because otherwise you break the system, right? So in this simple example, I will be using, but later I will show you the safer way to do it, which is to actually import the module and then use the prefix notation to avoid this name clashing. Okay. But for now, let's just do it this way. So if you want to run the code from the Markdown file, you can put your cursor inside this chunk and you can press Shift Enter or Control Enter. And this will send the code to the console. Okay. If you do Shift Enter, it will move to the next piece of code. If you do Control Enter, it will stay there. Okay. By the way, if you've ever used R Markdown in RStudio, this is exactly the same. So in RStudio, you can also have these notebooks with the code chunks, and it works exactly the same. Or when you send R code from the script, you also do Shift Enter. Okay. Okay, so we have these rules. We start with A becomes A, B becomes A. How do we do these in VPL? Okay. So we want to keep track. Remember, in VPL, you need to construct a graph. Yes, there's a
No.
question. You want to create a graph and you need to keep track of these A's and B's. And you want to separate them, right? Because sometimes you want to replace the A, sometimes you want to replace the B. So you need two types of data to distinguish whether a no is A or B, right? So you need to define two types of the data types, A and B, okay? And they need to inherit from this node that is exported by Vita Pipeline, okay? So the simplest way to define a data type is this piece of code you see here. So this is now Julia knowledge, okay? So with the keyword struct, then the name of the data type, then if it inherits from an abstract type, that will be like an abstract class in Java, then you use this piece of code. And then you put the keyword and to say, I have finished the definition of my data type. Later, we will see more complicated definitions where we add fields inside, right? Because we want to store the length of an internal, we want to store something, okay? So this basically means I define a data type called A that inherits from node, okay? And this one means I define a data type B that inherits from node, okay? They don't contain any data because this simple algae model, I don't need to store any data in the nodes, right? Now you see one detail, and it's that this code is stored inside a module, okay? And I hate that I have to do this because I need to explain some very technical Julia things in the first tutorial. Julia is very dynamic, meaning that you can change your code and rerun it and it will work, except when you define data types. If you create a data type with a certain name and you run the code in Julia, and then you want to change the definition of the data type by adding new fields, for example, and you run it again, Julia will give you an error. So per session, you cannot redefine a data type. Okay.
What is data type again?
Data type is this. It's like a class.
Did you say struct or
Yes, right.
length or boolean or?
Yeah, those are data types. Yeah.
Yeah. Okay.
Of course, boolean is defined in Julia itself, right? But that will be an example of a data type. But for the user-defined data types, you cannot change the definition within a Julia session. You will have to restart Julia console. And that's very annoying. So what I recommend is that you put them inside a module. And because that is sort of the hack that you can use in Julia to allow redefinition of data types. There are other ways to do this. If you search, because this is a hot topic in the Julia community, how to do this. So there are some packages that allow you to define data types in a way that you can redefine them, okay? So you can also search online for alternatives, but this is sort of the canonical way to do it. Yes.
What do you mean redefine? So if you want to change A from struct to something else, or?
Yes, let me see. I'm going to run this piece of code. So now I've defined A. I type A, okay, but let's say, oh shit, I forgot to include something. So actually in A, I need to include some data, right? So now I come here and I say, I need to include some data, which is of type flow 64, right? And then I run this code again. Invalid redefinition of constant A. And that means you're trying to modify it. When you run the definition of a type with the same name, then you will say, sorry, we don't allow that. And it's very annoying, but this is needed for performance reasons, apparently. And it hasn't gone away in more than 10 years. So I'm not sure if it will ever go away. Maybe in the future versions of Julia, this is not a problem. Again, there's packages that allow you to do this in a special way, like prototype data types and things like that. But my recommendation is that you can use to do it in the canonical way from the beginning. And that means that when you define data types, put them inside a module, and then you import this module. Okay? So a module is like a namespace. So each module, you can have the same variable in different modules, and they are independent.
Is it the same as module in Chrome? Because I will also say module.
It is similar to the modules in Java. So different modules in Java can contain the same variable, same name, but they are independent. And when you access them, then you prefix with the module name. Yes, so it is the same.
Okay.
And the module is like a private function, let's say.
It's more like a namespace. It's a namespace. So basically a package is a module. So we can say import virtual panda, and then we're importing the virtual panda module, then we can access the functions and data types inside, right? So this is basically kind of the template code that I recommend that you use, and in all of my tutorials I do it like this. Whenever you have data types being defined, put them inside a module, and then you can do import module, or you can do using the module, but I recommend to always use import, and then you prefix by the module, right? So in all my tutorials, you will see that I have all the types defined at the beginning, because then you can develop your code in a much more dynamic way.
So it's not, module is not in the graph.
No, this has nothing to do with the graph. This is pure Joule.
No, but I mean, if you're now making a structure A
Yeah.
and a structure B, and
Yeah.
eventually you're gonna run an A, and A is gonna become an AB,
Yeah.
then you're gonna create a graph.
Yeah.
And then it's not gonna be weird that there's a module. Doesn't
No.
matter.
You will see.
Okay.
So we create a module
Yeah.
algae, and we put all of our definitions in there. And you can see that inside the module, I need to load the package again, because each module is independent. Right? So inside the module, I load the virtual plan lab to access node. So here I'm importing the node for virtual plan lab, and then I define the types A and B. Okay. And I can run this code. So now we're going to construct the axiom and the rules, and then we'll put them together in a graph. Okay. So in this case, the axiom is just one node. Okay. So in this case, we just create an object of type A. And because I have it in a module called algae, then I call algae.a and the brackets, just like any constructor. And this is just an object of type A. Okay. You don't have to call it axiom, you can call it whatever you want. That doesn't matter. Okay. Now, how do we construct rules? Okay, so a lot of text here. But basically, a rule in VPL is composed of 3 items. The first one is the type of node that you want to replace. So that's sort of your first filter, is that I want to replace nodes of type A, or I want to replace nodes of type B. That's sort of your first condition. And I treat that as a special condition for performance reason. Okay? So let's say in the future, if you're trying to replace a meristem, then the first piece information that you need for construct the rule will be, okay, type meristem. Then you can define a function that further refines the nodes that you want to replace, right? Because you might say, I don't want to replace all the nodes of type A, maybe I want to replace nodes of type A that meet certain conditions, right? And this could be based on the data stored in the node, or it could be based on the relationship of the node to other nodes in the graph. Like I only want to replace nodes of type A that have a certain parent of a certain type, for example. Okay? So that is a function that you have to write that is used to further filter the nodes are going to be replaced. Okay? And then the third component of the rule is a second function where you create the new node or nodes that will be using the replacement. Okay? So if we go to this example, so let's go to the HTML version. These rules are very simple. So rule 1, I'm targeting all nodes of type A. There's no further conditions, right? And it's going to be replaced by a subgraph, which is A followed by B. And here it's even simpler, replace B by A, right? So in these cases, the filtering is very simple. We only need to know the type. We don't need to check any more conditions. And this function will create A followed by B. So that's like a little graph in itself. and in this case, a function will create the node A. Okay. Later in the rest of the tutorials, we have more complicated. Okay, that is all the text explaining this. Okay, so how do we actually do it in VPL? So you have this rule function that creates rules, right? And it takes 3 arguments. The first one is the data type that you want to target. And the other 2 are optional. Okay, and their name, well, here you only see RHS, but I could also have an LHS, okay? Right? But these are optional, so you don't need to always specify them, right? So those 2 other arguments are the functions that you need to complete the rule. Let me take you to the website so that you also learn how to use the website. You go to the API, I go to graphs, let me search for rule. Yes, okay. This is the documentation for the function rule. So in the rule, you need the node type. That's the type of node to match. And then there are 2 optional arguments, which are name, LHS, and RHS. But this one is the function that is used to further refine which nodes you want to replace. And this is the RHS is the function that creates the new nodes. Okay. By default, so this is sort of a very, whenever you see this arrow in Julia, it's like a very compact way of defining a function. Okay. This basically means the function that takes an argument and returns true. So by default, if you don't specify this LHS, you will select all the nodes that match the type. Okay. So you have to imagine that first I give you all the nodes of a certain type, and then I run the function every one of those nodes. So if the default function always returns true, it means that it doesn't really do anything, right? It just said, yeah, all these nodes I want to replace. You only specify when you want to further refine your selection. And the default.
Why would you want to do that? Why don't you put your selection directly on the first argument?
What do you mean?
Well, I mean, you
want
want
to just have some function.
You want to replace something with something else, right?
Yes.
So that's the left-hand side.
Yeah.
And that you want to replace. Yeah. So now there's the first search for the thing that you want to replace.
Yeah. No, you first for the type. You first select by type, and then you continue your. So your LHS is split into 2 halves. First the type, and then whatever else.
Right.
And I do this for performance reasons. That's the only thing I want to say. So it will be nicer for the user to just have one function, because then, I don't know, you could replace nodes of different types, for example, with the same rule, or, you know, you can have a very complicated thing. But one assumption that I'm making is that in FSPM, a rule generally matches a type of node. So that's like a special condition. I give it special status because that allows me to gain a lot of performance in the execution of the rules. If you don't specify the RHS, then by default, it will return nothing. And that basically means that you just remove the node. And so if you want to remove all the nodes of a certain type, then it's a very simple rule. You just say rule and then the type. And that will basically remove all those nodes from the graph. Right? And then don't worry about the capture. That's a bit more complicated. That's for context capturing, but I don't want to discuss that now. But this emulates a feature in growing, which is when you reuse a node at the right-hand side, because you want to use the data stored in there. Okay. So let's see how we create these rules. So remember, the first one was replace A by A plus B. So we define the type A as the first argument. We don't need further refinement, so there's no LHS function. And then the RHS is this function that basically creates A plus B. But remember from the slides that if you have a node plus another node, it's basically just connecting them sequentially. Okay. Which in L systems means 2 symbols that are next to each other. Okay. And then the second rule targets all the nodes of type B, and then it replaces them by A. Okay. Now here I'm using, as I said, this compact way of defining a function, which is called an anonymous function. You could also create a function with a name, right? So this is the syntax in Julia to create a function with a given name. Okay, and then you would use this name in here, right? So this code, okay, if I run this function, I could have also said rule1 is equal to rule algae type A, and then the RHS is the rule underscore one function. Okay, so this is the same. So either I define the function in place using this special notation, and you need to learn Julia to know what this means, right? Or I define a function with its own name. So this is sort of the independent function, and then I refer to the function when I create a rule. So in both cases, you get the same thing. The advantage of doing it in the first way is that for very simple rules, you can specify everything in the same place, and you don't need to come up with some function names. This is the kind of code that you will write when you're more advanced, but it's also the kind of code that is harder to read and harder to debug, right? So the second option is a little bit more friendly at the beginning, because then you have a function that you can call directly, and you can add some print statements if something goes wrong, etc., right? Is it clear?
Now you're creating your own new function.
Yeah.
That's already actually complex on its own. But then you're asking the function within a function. You're doing function within function, because rule bracket is already a function.
Yes.
That's already a pre-written function.
Yes, you can pass functions as arguments to functions.
Yeah, no, I understand that you can do that, but it's not per se easier for starters. I would personally say, but that would be my. No, but I'm just saying, like, how do I know the difference between? Because now you create a new function, right?
Yeah.
Out of a rule. It's called rule without. But the other one, the rule with capital rule, it's already a pre-written.
Yeah. Yeah, you get that from importing the virtual function.
Yeah. Okay. So sometimes that is.
So basically, at the beginning, you can create your own function, give them names, and then just use this approach. Okay. This, I would say, do it if you feel comfortable with it, or just learn the pattern, because I think most rules are going to be relatively simple, right? And I like this approach, but I also understand it's the kind of thing that makes your model harder to read. But yeah, as I said before, this is a Julia issue. So any way in which you can create a function will work. So now we have our axiom and our rules. So how to create a graph? Well, we have the graph function, and as an argument axiom and argument rules. So you just give it the axiom and the rules, so the objects that we created before, and that will create your graph. Okay, so we have a dynamic graph with one node of type algae A and two rewriting rules. Okay? So basically, graphs are just packaging them together. Okay? If you now want to execute the rules, right, because you want to start replacing the nodes, okay, then the only thing you need to do, actually the only thing you can do, is called the rewrite exclamation mark function on the graph object. So when you say rewrite and then the graph object that you created, it will execute the graph rewriting rules and it will update that object once. It executes all the rules once. Okay? So this will be equivalent to doing run in Golang. Yeah. But the difference here is that you decide where in your code you do this, right? It's no longer done for you automatically. You have to decide where in the logic of your code you're going to execute the graph rewriting rules, right? And that is important because you can, let's say, calculate a similar production first and then execute the rules, let's say at the end of the day, or you could execute the rules at the beginning of the day and then run your line interception, photosynthesis, etc. after that. Right? That's a decision that you need to make.
We do that in Golang also, right? You also set the order of first I do the light model, then I do development, then
Yes.
right, and
But do you know when you execute the rules?
Yeah.
because that's written in your run.
Yeah, it's in growing, it's the
Because the run in
Yeah.
growth is also because we use that. You could also have called it.
within your run, you can still
summer.
specify.
Yeah, you can, but you also don't have to do it. If you don't do it, it will run at a specific moment. Because I remember the early
Basically, run is just saying run this block of code,
Yeah.
and then that block of code can be whatever, and it can contain rules, it can contain
When
principles.
inside the block of code, you cannot always rely on the order of the rules as you write them, because that's a bit of a mystery in growing. Most of the time, it's executed like that. If you want to be sure, you have to write this derive command.
Do the job. Okay, that's correct.
Yeah.
Yeah.
Otherwise, you're not always
That's true.
sure.
The way it works in VPL is that the order of the rules do not matter. So the way it works is that when you call rewrite, the first thing it does, it runs the left-hand side of all the rules, and it keeps track of all the nodes that are matched. And I check that a node is not matched by more than one rule, because mathematically that doesn't make sense. The way graph rewriting a rule is a parallel operation, so a node can only be matched by one rule. Okay? Because if you have two rules matching the node, then you have this uncertainty of which rule do we apply first. And then once I make sure that there is no node being matched by more than one rule, then I apply the replacement to those nodes. Okay? So it is strictly parallel, not in the sense of running multiple cores, but in the sense that you always rewrite, you apply the rules to the initial state of the graph, and then you get a new state of the graph, right? And that has to be done in this way, because otherwise mathematically what you're doing is not correct. And for that reason, I don't let you do it yourself. That's why there is the rewrite function, because I don't want to give you the chance to screw up your model by running the rules in whatever order. With queries, you can do whatever you want. You can run the queries whenever you want, as often as you want. But the rules are special because I need to make sure that all the rules are executed and that they don't match more than one example. Okay.
So I have trouble that my rule is not defined. So where did I?
Because you didn't run the code before.
Yeah, I did.
So you
But
just
I
open up.
even tried it twice. So first,
And you installed virtual lab at the beginning.
yeah. So I even did it twice. So first I did this and then
No,
control.
there's something
but
else
It doesn't
before.
work. Yeah, I did. Maybe not. Okay, maybe not.
Shift enter.
So if what if you do control enter? It just
Yeah, if you do control enter, the cursor stays there. If you do shift enter, it jumps to the next one.
because it doesn't say that I did it, which is interesting.
Can you do shift enter?
No, but then it doesn't say in my console or in my terminal. It doesn't say that I actually
Select
execute.
shift enter, maybe. I know you saw.
Like now it says that I run it,
Yeah.
but it doesn't show me here.
Okay, so
Which is confusing.
there's some settings in VS Code. So you can set up VS Code in such a way that it echoes the code that runs the console. So it
Yes,
shows on the
please.
console.
Yeah.
Or you can have different settings. I don't remember right now how to change that.
It's okay.
Yeah, no, that's okay. But I was just more like I was confused because normally if you say run, then it comes in the console.
Yes,
Normally in
yes.
RStudio.
I think you may have the default
Yeah.
settings.
Now I just
They
started
take mark.
paste it.
Yeah, the consequence of that, it's also not in your history. If you arrow up, you won't find
Yes,
it if you run
exactly.
it from the
Exactly.
text, which is annoying. Sometimes you want to rewrite again and again and again.
Everything in my terminal, so I know for sure that I run it.
This comes.
Okay, so we have executed the rules. So now we have an updated graph. And if I type organism in a print, the only thing that I get is that I have a dynamic graph with two nodes of type A and B. And yeah, you're just going to get this comma separated list. So I didn't make it more sophisticated than that. And the two rewriting rules, right? So printing the graph itself does not show you the internal structure of the graph. If you want to visualize it, okay, then you need to import a graphic backend. So here I'm using GLMaki, okay? and then you can draw the graph. And so there's going to be two functions for visualization: draw and render. Render is to do the 3D rendering, and for that you need to have geometry. Draw will draw the graph itself. So what that means, you can run draw. Again, the first time it takes a little bit of time. It needs to compile all the code for drawing. Okay, I think, yeah, there you go. So this is my very sophisticated algae model with nodes A and B, separated by an arrow. Yeah. When you draw the graph by default for each node, you're going to get the type of node. So this is node of type A, node of type B. So this reflects the data types that you created. Okay. So if you call this potato, then this will say potato. And then this unique identifier, which is going to change. So it doesn't have any special meaning. So later it might be 322 or 1055. It doesn't really have any meaning, except that if you want to extract a particular node from the graph, you can use that number. Okay. So if we go back here, I don't have it in the code, but let me see. I can go to the console and I can say organism square brackets 2. Okay, because I saw that there was a node with the ID 2, then this will give me something, which is a bit complicated, but if you want to extract the data, it's stored and use the function data, right? And this gives you back the object that you stored. Okay? So if you use the unique identifier in square brackets, okay, and then you run the function data on it, what you get back is whatever you put in the graph, right? If you don't do the data, then you're going to get some of the internal details of the implementation of the graphs, which is not really useful, okay? But basically, this is one way to extract nodes. Of course, this is not very reproducible because these IDs are going to change over time, right? So later we show you how to do this with queries. But when you're debugging your model, this could be useful, right? Because, oh, I want that particular node, what's going on? And you can access the node like that. Okay, let's grow our algae a little bit more. So we want to do 4 time steps. So I just create a for loop and I execute rewrite 4 times. Okay. And now I can draw again my organism and now get all of my nodes, right? And you can see that the ID numbers are now much higher because I've been doing a lot of graph replacement internally, and the idea is that you have a global counter for the ID, right? So the IDs are always increasing throughout your simulation.
You reset it?
Yes. Don't know if I have an example. Yes, it's actually the next code. So if you want to reset the ID, you need to import plan graphs, the package plan graphs, and then call the reset ID function. So this is not exported because I don't think you need it. But if you know what you're doing, you can run this function and it will reset the counter. The graphs that have already been created, the IDs are already there. But by resetting the counter, when you now create new nodes, the IDs will start again from 1, 2, 3, 4. I only recommend to do this if you're going to create your graphs again from scratch. Because what can happen is that if you create a graph, you do some graph rewriting, then you reset the ID and you continue doing graph rewriting, you could end up with 2 nodes with the same ID, and then you broke VPL. Okay? And I don't know what will happen. You may crash the visualization, I don't know.
This doesn't work for me, this import plant graph kit, right?
It doesn't work for you?
Yeah, the second one? Reset ID? Oh, yeah. No, I get some error message, doesn't matter.
You also had to edit separately.
Yeah.
So, okay, it could be that to import, you need to specify add client graph. That will not install it, but maybe makes it available. Because it is there, but maybe it's not you cannot import it if you don't do the add time graph explicitly.
But with reset, I meant, can you reset your model so it goes back to the axiom just by?
Oh, you mean reset the? Sorry.
Just need to start from the start again.
No, so that is up to you, because when you run the rewrite, it will rewrite in place. So what you can do is you could create a copy of your original graph and then just call it again.
Yeah.
Or you can rerun the function that creates the graph.
Yeah.
Okay. But the rewrite changes in place. Be careful when you do copies in Julia, because again, for performance reasons, most of the time Julia will do what is called a shallow copy, which means that you're still modifying the original object indirectly. Right? There is a function called deep copy that will try to truly create an independent new object that is not linked to the original one, but sometimes it does not work properly. So I recommend a style when you create objects from scratch rather than reuse existing objects.
Are more people trying its computer still calculating those for loops? Because mine is still busy on.
Really?
Yeah, I don't know what.
That's enough. Any questions so far?
Can I also exit it?
It's already been an hour and we just did one very simple tutorial.
So the copy is like the pointer.
Yes.
Last.
Yeah.
So you basically have immutable and mutable objects in Julia. So struct is immutable, which means that it always creates a true copy, but you cannot modify the struct once you create it. So it's like sometimes called static in all languages or something like that. Right? If you want to be able to modify the objects in place, then it has to be mutable, and then it will create a pointer. If you do a copy, a deep copy will try to create a true.
Any copy, like if I say, for example, A equals B,
Yeah.
then the A changing A will change B.
Yes. If it's mutable, if B is mutable. If not, then they are immutable. Yeah, so the graphs are mutable.
And if you want to make a copy that is not a pointer, how do you do that?
The decopy function tries to do this, so it tries to create what's called a recursive copy, so that you get an independent version of the mutable struct, but I cannot guarantee that that will always work. My impression is sometimes it does not work. So what I recommend is to have a function that creates the object from scratch every single time.